Hello everyone, today in this video we'll be discussing the fifth module of ADA, and in this module we have the following topics. So in these topics there are some algorithms which you need to know, and how do you solve these problems. Okay, I'll be discussing all of this in depth, and before starting please do like and subscribe. It helps me make more videos like this, and if you watch this video till the end, easily you can score more than 80% marks. I'll be discussing all the important questions as well, and if you have any questions you can DM me on Instagram. Now starting with the first topic, which is decision trees. Okay, so it is used to find the performance of different algorithms. We have different algorithms, right? So all of these algorithms, in between the algorithms, which algorithm is performing more better than the other ones, that one will be finding out, and we'll be finding out using the decision tree. Okay, so how using a decision tree we'll be finding out. In the decision tree, what we'll be doing is we'll be having one thing here, like a is less than b. Suppose an algorithm checks a is less than b first. Okay, then what happens, it will check if it is true or not, if a is less than b or not. If it is true, then we'll check a is less than c, right? If a is lesser than b, then we have to next check a is lesser than c or not. If it is true, means a is the smallest element. If c is lesser than a, means c is the smallest element. If b is lesser than a, then we'll check b is lesser than c also or not. If it is lesser than c also, means b is the smallest, else c is the smallest. So this is the thing which we need to do. Okay, so this is how we construct the decision tree. And the height of the tree means how many iterations are needed to reach the end. Okay, and the worst possible combination which will cause us to reach the most depth, that is called as the depth of the tree, and that will denote the performance, because performance is denoted by the worst case scenario, how much maximum time it can take. Okay, so that will we will be able to find out using the depth of the tree. More depth means it is more uh, things are there, more things are needed to be calculated, and those things. Okay, so the more depth means the more worse the performance is. Okay, so this is how we will be using the decision tree. Okay, and we'll be calculating the height also. Now this is the for the selection sort, again a different algorithm. Here also we'll be finding out the height, and based on that we'll be able to see what is the performance of it. Okay, now next topic is P, NP and NP complete problems. Okay, P means what? Polynomial. Okay, the class of problems that can be solved in polynomial time is called P problems. Okay, so some problems will be there, like the algorithms will be there. In that we will be not taking much time to solve it. There are algorithms we will just calculate this and it will get an answer here. That is called as polynomial time. Okay, because if we try to find out the time complexity, it will be something like 5n, 6n square, 7n cube, like that. It will be in the numbers here. But if some algorithm is taking like 2 power n, 3 power n, based on the number of inputs, it is getting exponential. That is called as an NP. Okay, that is exponential time which takes, that is called as NP. Okay, non-polynomial time. And some problems can be solved using the known algorithm, cannot be solved using the known algorithm. It is called undecidable problems. If it can be solved, it is called as decidable problems. What is halting problem? When we give an input to the computer, it gives us an output yes or no. It does not stop or halt in between, continuously finding out the answer indefinitely. If that situation happens, that is called as a non-halting problem. Okay, halting problem means the problem in which we give the input and a definite output will come, either yes or no, or whatever the answer it is. That is called as a normal program, which is halting problem. Okay, next, some problems which cannot be solved in polynomial time. Examples are Hamiltonian circuit. In Hamiltonian circuit, we will be having some nodes here, and you have to traverse all the nodes and do not repeat another node and reach the last node. So reach the first node which is started from. That solution, to find out if a solution exists or not, that is called as Hamiltonian problem, and we will be discussing this in the upcoming topic. That is the Hamiltonian problem. And traveling salesman also is same. There are n cities are there. The salesman has to visit all the cities, but to visit each city there is a cost associated, from here to here, here to here, here to here, which is the least cost I can take without repeating any city and reaching the starting position. That is a traveling salesman problem. Knapsack problem means you will be having a maximum weight present here, and we have to put the items in this, and which item if we put, that will give us the maximum profit. That is the knapsack problem. This also we'll discuss in depth. Then is a partition problem. Okay, a similar kind of problem where the disjoint subsets will be there. We'll be calculating the sum of these subsets. Okay, and bin packing problem is also same thing. There will be bins which is not larger than one, and we'll be putting the items inside it. And graph coloring problems, there is a graph present here. Suppose that this is a graph. In this graph, no two adjacent nodes should have same color, different color, and this also has to be different color. Means it, the suppose that this is red yellow, red. This is possible because red and red are not interconnected. Whichever is interconnected, that should not have the same color. That is a graph coloring problem. And integer linear programming problem, this is also related to the linear inequalities and the equations. Okay, so these problems are some of the problems which cannot be solved in the polynomial time with the known algorithms. Okay, now what is non-deterministic algorithm? It is which does not halt on some input and definite answer it does not exist. Okay, so if you give an input, it tries to calculate indefinitely, it goes in a infinite loop. That is called as non-deterministic algorithm. What is class NP? NP is the decision problems that can be solved using non-deterministic polynomial algorithms. Okay, means there will be polynomial time will be there. That is the NP, but it is still non-deterministic. Okay, it can go into an infinite means processing situation. Okay, now the question is P is equal to NP? P means polynomial time algorithms equal to non-polynomial time algorithm. Means can we find out a polynomial time for all the non-polynomial time which we have now? Is that possible or not? But that question remains unanswered yet because research keeps going on. Okay, so P is equal to NP, that is an unanswered question as of now because research is going on. Next is NP complete problem. What is NP complete? It is suppose before NP complete you need to understand what is polynomially reducible. Suppose that there is a problem D2. Okay, and there is a problem D1. If I can reduce the problem D2 into D1 and I know that D1 it can be solved using polynomial time, then obviously D2 also can be solved using polynomial time. That kind of logic is called as the polynomially reducible problems. Okay, so decision problem D is said to be in NP complete if it belongs to the class NP and every problem in NP is polynomially reducible to D, which can be polynomially solved. So basically we are reducing the problem such that it can be solved polynomially. That is called as NP complete problem. Okay, now the actual problems and the different types of questions, they can ask you about the n queens problem. Okay, so basically if you know chess, in chess what is the thing, the queen will be present here. Okay, and there will be the rows and the columns will be there, right? So queen can go like this, like this, like this, like this, in the same row, in the same column, and in the diagonal also it can go. So we have to place n queens. Okay, n queens means can be 4 queen, 5 queen, 6 queens in a n cross n board. Suppose it is 4 cross 4, so 4 rows 4 columns will be there. Okay, 4 rows and 4 columns, just like in this diagram. So 4 rows 4 columns are there, we have to place 4 queens. If you place 4 queens like this, it cannot be possible. Why? Because these queens will be beating each other, so that is not possible. We have to place the queen such that it will not be, the other queen will not be in the same row and same column. So we have the options left is this. Again, in this rows and the columns, another queen cannot be placed, so we'll place a third queen here like that. Okay, so we have to place 4 queens in this matrix such that no queen can attack another queen. Okay, means if I place a queen here, no other queen can be placed in these places. Okay, the diagonal. Got it? That is called as the n queen problem. Now we'll be using the trial and error method to find a solution. So the situation is that there is 4 rows, right? So first queen will be placed in either of these, second queen will place either of these, third queen and fourth queen. So we'll start from the first. We'll place the first queen here. Okay, and is there any issue? No. Then we'll bring the second queen and we'll be placing here. Is there any issue? Yes, it cannot be placed here. Why? Because if it is placed here means it will attack, right? So what is the other way? Can we place here? The first queen is here, second queen here? No, we cannot because diagonal, right? So we'll be placing the first queen here. Can we place the second queen here? Yes, we can place. So first queen, second queen is done. Third queen, can we place the third queen here? No, it will attack from here. Can we place the third queen here? No, it will attack from here. Can we place the third queen here? No, it will attack from here. Can we place the third queen here? No, this will attack from here. So this position is causing to attack from here, here, here. So this position we need to change. So next what we will do, this queen is here, this queen is here, we will be placing here, and this queen cannot attack this one. Fine. Now we will place this third queen here. Can this queen be placed here? No, because it will attack. Can we place the second, third queen here? Okay, suppose this is first queen, second queen, third queen. Can any queen attack this one? No, cannot, right? So the third queen will be placed here. After placing here, fourth queen will find out here, 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 here. But when we reach here, this queen will be attacking. So this position which we find out, this is fine, but this one is attacking. So like that we'll find out all the combinations, placing this here, here, here. If nothing happens, then we'll place the first queen here and see, like that we'll be doing. Okay, so that is called as n queens problem. And to solve it using the trial and error method, this is called as state space. Okay, state space they can ask in exam. Make the state space for the n queens problem and explain the n queens problem. So initially there are no queens, this will be the grid. Now first queen if I place here, okay, it will be placed here, there is no issue. Then if I place the second queen also in the first column, means here it will not be possible. Second column if I place, that will also not be possible. Third column if I place, it will be possible. So a grid is made here, right? Third column it is taken. I place here, it is fine. Okay, second row and third column, like that. Okay, next I have placed here, done. Now but if I place in the first, second, third or fourth row, the third queen, here I place, it gets killed, here I place, gets killed, here I place, gets killed, here I place, gets killed. So because of this I cannot place anywhere, so it will be an end situation. Now if I don't have a solution here, the next position is this one, so I will be placing it here and checking. Now if I place here and check, first position, can I have a solution? No, I cannot have, it will kill here. Second position, can I have? Yes, second position I can have. But okay, second position I can have, I'll keep it as of now. Okay, third position can I have? No. Fourth position can I have? No. So second position is looking fine, right? So we'll place a queen, third queen in the second position. Now where will I place the fourth queen? Can I place here? No. Can I place here? No. Can I place here? No. Can I place here? No, because this queen will also attack, this queen will also attack, double attack will happen here. So this position is not right. Okay, and I cannot place it in the other places also, here and here also, right? So this thing needs to be changed. Okay, this one cannot be changed because it is end. Okay, so if this also cannot be changed, we'll go back and change this one. This one if we change, we'll take the second row. Okay, second row will place here, and again we will check. First queen can, second queen can be placed here, 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 or here. Here it can be placed, so we'll be putting it here. Second queen is placed. Third queen will check. Third queen can be placed here only, the first row, right? Then fourth queen. If the third queen is placed here, fourth queen can be placed here. No. Here, no. Here it can be placed. Yes. Here it can be placed. So we'll get an answer. First queen is here, second queen is here, third queen is here, fourth queen is here, and no other queen can be attacking. Right? If you observe carefully, no other queen will be attacking any other queen. Right? All are in separate rows, columns, and diagonals. See, this one will also not attack. Okay, and this one will also not attack. Row, column, and diagonal. Okay, and this is also on diagonal. So if you observe carefully, this is the final solution you need to arrive at. Okay, in the NPN's problem, and explain whatever I've explained. Next, Hamiltonian circuit problem. In Hamiltonian circuit problem, we'll be having one graph here. Okay, and we'll be starting from one node. Suppose we start from A. Now from A, I have to go to all the nodes. I have to go to B, C, D, E, and F. But the rules are two. First rule is I cannot repeat a node. Means if I go to B and F, I cannot come back to B. I have to continue. Okay, because I cannot go to one node two times. And another thing is, if I go like this, like this, like this, like this, like this, I reach the first node, but one node is missed. None of the node should be missed, and none of the node should be visited twice. That's the problem. Okay. Now, how do we solve it? We'll be solving it using this algorithm, which is the trial and error. So A is here. So A to B I can go. A to B I can go. I have went to A to B. Then I can go to C or I can go to F. Right? Two options are there from B, C, and F. If I go to C, I have again two options, D and E. Right? D and E. If I go to D, I have an option to go to E. I can go to E. If I can go to F, I can go to F. But I cannot come back to A. Why? Because F is dead end. I cannot come back to B. B is already visited. I cannot come back to E. From E only I came here. Right? So I did not reach the A. So that is not a proper solution. Now from C to E if I go, okay, means A, B, C, and E if I go. Then if I go to D or F, two options are there. D and F both are dead ends. I cannot reach back to A. Right? So in these situations, either of the node is getting missed. See, if I go like this, this node gets missed, and I do not reach the final solution also, right? So these are not the solutions. If I go from B to F, if I go to B to F means A, B, F, and I go to E, then I go to C, then I go to D, then I go to A. Here all the nodes are visited, as well as none of the nodes are repeated, and I have reached the first node, right, the source node. So this is the solution for the Hamiltonian circuit problem. Okay, this much thing you have to make and explain. This is the state space tree. Okay, that is a compulsory thing you need to make in exam, otherwise you will be using, I think, more than half marks you will lose. Okay, next is subset sum problem. Okay, in this problem you have some numbers. Okay, for example, we'll take directly an example. You have 3, 5, 6, 7, and you have to find out the sum 15. You have to select the numbers from here which will form the sum exactly as 15. So which will be those numbers? 3 plus 5, if I do, it will be 8. 8 plus 6 is 14. That's not possible. If I take 5 plus 6, it will be 11. 11 plus 7 will be 19, 18. That is also not possible. If I take 6 plus 7, it will be 13. 13 plus 3 is 16. So which is the solution? The solution is, you have to find out 6 plus 5 is 11, and 11 plus 3 is 14. That is also not a solution. So is there a solution? Yes, there is a solution with 3 uh, 3, 5, and 7. Okay, if you do 3, 5, and 7, we'll get the solution, right? 3 plus 5 plus 7 is 15. 5 plus 7 plus 3 is 10. 10 plus 5 is 15. So this is the solution which we need to form. How we will do it is, first we will not select any element. Then we will see, first I can select 3 or not select 3. There are two options. Okay, we will be dividing it. Next, if I select 3, I have two options: select 5 or not select 5. Then I have another option. If I select 5, I have select 6 or don't select 6. Now if I do it 3, the two options are with 5 and without 5. If I do with 5, it will become 8. The next element is 6, with 6 and without 6. With 6, if I do, it will be 14. Okay, but I have to find out 15, and after 6 I cannot select 7. Why? Because if I select 7, 14 plus 7 will be greater than 15. I need 15 answer. So from here I cannot take 7 nor reject 7, because if I reject 7, it will be just 14 left. Okay, I need 15. So this is not a right answer. Now we'll check the other one without 6. If I do not consider 6, it will be 8 only. 8 plus 7, I'll select 7. If I select 7, the solution will be formed. If I don't select 7, the solution will not be formed. So this is one of the solutions. Like that, we'll check here also. Without 5, with 6, without 6. What will be the sum? If it is greater or lesser, we will be rejecting it. Again, here also the same thing. The final sums which we get, if we are getting greater or smaller, we will be rejecting it. And if you find out all the possibilities with all the numbers, we will be finding out at one solution. That is my final answer. So which is the answer for this question? The answer for this question is 3, 5 and 7. This is the answer for this question. Okay, this is the subset sum problem. Okay, and this is the algorithm for it. Next is knapsack using branch and bound. Okay, you can do knapsack using two ways: branch and bound and approximation method. Okay, both are asked in the exam, so listen carefully. So knapsack, I already explained. You have a bag, and in the bag you have to put items. Each item has a weight, such that if you put the items, it should not exceed the limit of this bag, and whatever the items you put, if you sell those items, that should be the highest profit. Okay, let's take an example. Item 1, 2, 3, 4 are there. Weight is given for each of these. Value is also given for each of these. In this algorithm for the branch and bound, what you have to do is find out value by weight ratio, because if you find out value by weight ratio, you will be able to get for one weight what is the value I'm getting. For one, suppose it is kg. Okay, 4 kg I'm getting 40. 1 kg what I'm getting 10. 7 kg I'm getting 42. 1 kg what I'm getting for this 6 in the item 2. Third item, for 1 kg I'm getting 5. For fourth item, 1 kg I'm getting 4. Now I have these answers. Now in these answers, if I observe carefully, for 1 kg I'm getting 10 for this, 6 for this, 5 for this, 4 for this. So obviously the priority will be the highest profit. So for 1 kg, within 1 kg I'm getting 10 profit here. I'll be selecting this one. And once you select, I have to include all the weight. Okay, means if I select this item, I have to put 4 kilos. Okay, I cannot put just 1 kilo and go. Okay, so the total capacity is 10. I cannot select all the elements. First we will check if we can select all the elements. 4 plus 7 will become 11. 11 plus 8 will become 19. I do not have that much capacity, so I have to select some items. How do we do that? We use the branch and bound algorithm, in which we'll be finding out the upper bound. Upper bound's formula is given here. So this formula is very simple. It's not as complicated as it looks. What you have to do is, you have to find out, you have to make a box like this. Okay, initially we'll be not selecting any item. If you don't select any item, the total weight will be 0, right? If I don't select any item, whether there will be any weight or not, it will not be there. And value also will be there or not, any value. There is no item, what value will be there? 0 value. And upper bound, we have taken 100. How we have taken 100? Using this formula. In this formula, you will put V. What is the V? Current value. Okay, so current value, it is 0, so I'll be writing here 0. Okay, and W minus W. This W is the total weight, which is obviously always it will be 10 only. So here it will be 10. 10 minus current weight. Current weight is given here, which is 0. How many items you have put, that weight is given here, and how many items value is there, that will be written here. You'll be using this W and this V in this formula. Now we have substituted V as 0, okay, and W as 10, and this W as 0, because the current weight is 0. And what is this one? This is the ratio. Okay, value by weight ratio, and you have to find the value of weight ratio, the next one. Okay, means 0th element is here. Okay, first elements I have to take. Okay, the next element I have to take. If I'm considering 0 element, I have to consider the first element's weight ratio, 10. So I'll be substituting this part as 10. So it will be 10 into this answer, and this answer here I have got as 10. So 10 into 10 is 100. 100 plus 0 is 100. We'll be substituting the UB value as 100. This is how you have to calculate UB value at each point and substitute. After you have done that, then two options comes: including first item or not including first item. Including first item, not including first item. First, let's consider including first item. Now if you include the first item, what will be the value of W and V? That's the first thing you need to write. The value of W will be 4. Why? Because its weight is 4. What is the value of V? V means value, 40. So we'll be writing 4 and 40. Then you will apply this formula. V is here 40, and W is 10 here. and current weight is W, which is 4, so 10 minus 4, and Vi plus 1, Wi plus 1. So we are in the first element now. We have selected the first element. We are considering the first element. In both cases, without and with also we have considered the first element. So here the first element is this one we are considering. We have to select the next ratio. Next ratio is 6. So we'll be multiplying it with 6. So 10 minus 4 is 6. 6 into 6 is 36. 36 plus 40 is 76. So 76 will be written here. Done. Now we'll be considering the without one. When we consider without one, the weight will be 0 because we have not included the first item. So weight will be 0 and value will also be 0. What is UB? UB, again we are in the 0th element only. Okay. Sorry, not the 0th element. We have considered 1, right? We are including, not including, that's the secondary matter, but we have considered one. Okay, considering matters. We have considered one means we have entered this zone. When we enter this zone, the next ratio should be taken. In this zone, the next ratio is 6, so it will be 0, which is the V value. V plus W is 10 minus the small w is 0 into 6 is the next ratio, so it will be 10 into 6, 60. So this is the answer here. Okay, just keep it as such. Then you come back again here. You have to expand each nodes. Okay, so inferior to it, this I'll explain at the end. Okay, so you have to expand each nodes. Here you got as 76 and here you got as 60. You have to always expand the higher node. Okay, remember this, I repeat, you have to always expand the higher node. Okay, higher value which is there, that you have to expand. Now I have considered the first item. What is my next step? I can consider second item or reject second item. If I consider second item, I have come in this zone, right? If I don't consider also, it is in this zone only because we have considered the 2 here. Okay, with or without, that's not an issue. Okay, now in this zone I have come, and if I include the second item, calculate the W value. W will be 4 plus 7, which is 11. 11 is exceeding this, so since it exceeds, we have to stop it here. Okay, we cannot continue, it has exceeded the value. Okay, so if you don't consider this item, what will be my weight? Weight will be 4 only and value will be 40 only as previous one, because we have not considered any other new item. And UB's value will change. How will UB's value change? Because I have come into this zone, and in this zone what I have to do is apply this formula. V, which is 40 plus 10 minus the current weight, 4, 10 minus 4 into next ratio of which? Next ratio of the zone I am in this zone, so next ratio of this is 5. So 5 I have to multiply with 10 minus 4. 10 minus 4 is 6, 6 5 is 30, 30 plus 7, 40 is 70. So I'll be writing 70 here. Done. Now again, I have 70 here, I have 60 here. I have to expand 70. Okay, the higher thing I have to expand. Now again, I can consider the third item or not consider third item. If I consider third item, what will be the third item's value here? It is 5 is weight and 25 is the value. So 5 is weight. So I have to add 4 with 5. So it will become 9 here. And the value is 40 plus 25, which is 65. Right? Value here it is given as 25. Now I have got the W and V value. I have to calculate the UB value. UB will be V plus 10 minus W into the next ratio. Now I am in third zone. Third zone's next ratio is 4. So I'll be multiplying it with 4. I'll get the value as 69. Now again, I'll be considering the fourth item. If I consider, it will become the weight will be 12, because if I consider the first, third and fourth item, it will become 4 plus 5 9, 9 plus 3 12. 12 cannot be taken. Okay, next, if I don't consider the fourth item, what will be the thing? If I don't consider the fourth item, the weight will be same, V will be same, but UB will change. How will UB will change? Because UB in that case will be 65, which is the value, plus 10 minus 9, which is W minus small w, into 0. Why I have taken 0? Because I'm in the fourth zone now. Fourth zone, after fourth zone nothing is there, so it will be 0. Okay, so I'll be multiplying this with 0, so this will be getting cancelled, and here it will be 65 only, so value will be 65. Now 65 I've got here. Okay, and I can expand this one also to check if it is greater than 65. I can do that. If I do, what will happen? If I don't consider 3, weight and value will be same only, but UB will change. 40, which is from here, plus 10 minus 4 into 4. How I've taken 4? I'm in the third zone. Third zone's next value is 4 ratio. So I'll be multiplying it with 4. What answer I'm getting here? 6 4s are 24. 24 plus 40 is 64. 64 I got here. But 65 I already have here. I cannot expand further this. Why? Because if I expand this further, it will be without 3, with 4, without 4. If I take with 4, okay, what will happen? With 4, if I take, it will become 3. That is fine. 4 plus 3 is 7. And I can take here also, which is 40 plus 12, which is 52. 52 I can take here. I'm getting a value 52 for the value, but here I'm getting a more higher value, which is 65. Here finally what value I will get if I don't consider the third value and consider the fourth value, I'll get the value 52. But here already I have higher one, so you can skip doing this. Okay, another indicator for skipping this is you have got a higher value and you have got a lower value. That means it is inferior to the node 8. This is the node 8 which I am considering. After reaching this point, this is inferior to this, so we will not consider this, we will not expand this. This is also inferior, which is 60, we will not expand this. Okay, and we have got a optimal solution here. How can we know if it's optimal solution? Because after this point there is no more nodes left, and the weight is also reaching the maximum limit, and there is no other expansion which can be which is greater than 65 here. So that indicates that this is the final answer. So we'll be taking this as final answer. And which are the items we have considered? For the value 9, you consider the 4 plus 5. Okay, 40 plus 25 is the final answer. Okay, that is the items which I'll be including and selling into another city. Okay, this is how you solve using the branch and bound knapsack problem. Okay, next is the knapsack using approximation method. So in approximation method, you need to understand the first thing is that how does greedy algorithm work. Okay, if we just consider a normally greedy algorithm, here we have considered the knapsack problem for the following instances. Okay, the knapsack total capacity is 10. Okay, when you include the items, the total weight will be 10. Okay, and the items and the weights are given here. What does greedy algorithm do is it will select the first item, and what will be the value here? 42. Okay, it will be taking 42 from here, and weight is 7. Next item it will take 10. Okay, means 7 plus 3 10. 42 plus 12 it will take. If it will take 42 plus 12, it will be 52. Okay, so again since the weight has been satisfied to the limit which is 10, it will not be considering further. Okay, but this is not the best solution. So what we do is we do another twist here. The twist is we'll find out value by weight ratio and put it in descending order. Means it will be the highest value weight ratio, value divided by weight. For 1 kg I will be getting these values. For 1 kg I am getting 10 for item 1, 6 for item 2, 3 for 5 for item 3, and 4 for item 4. Now we have put it in this way. Again, if we apply the greedy algorithm, here it will take the first one because it is highest, so it will be 10. Okay, and the value is 40. Okay, and weight is 4. Next it will take this atom, but it cannot take. Why? Because 4 plus 7 will be 11. It will be exceeding, so it will skip this one and it will go to the next one, which is 5. 4 plus 5 is 9. Weight is satisfied. 40 plus 25 is 65. 65 is also satisfied, and 65 is the highest answer which we can get here. In this situation we are getting the highest answer because there is no other value which is exceeding it. But this does not always happen. Okay, this does not always happen. If it happened always, then this problem will not be under NP problem. Okay, there are instances where it does not happen, but those are complex instances. Okay, so this cannot be solved using the greedy algorithm. So we need to find out another way. So we'll be using approximation method. So in approximation method, what we'll be doing, we'll be finding out some ratio, and we'll be using a k value. That means how many items we need to select at one point of time. Okay, so if I take an example, it will be clear. Here an example is taken with k is equal to 2, means at max 2 items can be selected. Okay, means it can be 0 items, it can be 1 item, or it can be 2 items in any combination. And when we do this and we find out the values present here, we'll be getting some values and we'll be selecting which is the highest value. Okay, so how do you solve this is 1 2 3 4 items are there, weight value and value by weight ratios is given, capacity is given as 10. Now subset is 0, means nothing is selected, so the added items will be 1 3 4. Okay, 1 3 4, if I add, it will be 4 plus 5 is 9, 9 plus 1 is 10. So if I add these values 40, 65 and 69, so it will be 69 here. Now after adding these ones, I am adding those elements which I can form, by using which I can get the highest value. Okay, so I have taken 1 3 4. Okay, next if I take one outside this, if I take one outside this and put it here, the remaining one will be 3 4, and total sum will be 69 only. Then consider 2. Okay, if I consider 2 means second item weight is 7. If I have 7, which elements can I select? Can I select 4? 7 plus 4 I can't do. Can I select 5? 7 plus 5 I can't do. 7 plus 1 I can do. So fourth element I will be selecting, so I'll be writing here 4, and total cost will be how much? If I select this, I'll be getting 42, and with this I'll select this, it will be 46, so we'll be writing 46 here. Now if I select 3, here, which items can I select? If I select 3 here, I can select 1 and 4, right? Because 1 3 and 4 can be formed. 4 plus 5 plus 1, it will be 10, and the value will also be highest, which is 69, so I'll be writing here 69. 4 means 1 3, again 69. 1 2 I cannot take. If I take 1 2, what will happen? 4 plus 7 exceeding the weight. 1 3 I can take with 4, it will be 69. 1 4 with 3, 69. 2 3, if I take 2 3, it will be 12 total weight, I cannot take it. 2 4 I can take. 2 4 if I take, it will be 7 plus 1 8, but it will be 46 only. If I take 3 4 with 1, 3 4 will be 29. plus 1 is 40, which is 69. 69 I'm getting here. If you observe carefully, we are getting most values as 69, and those have the same subset value 1, 3 and 4. So 1, 3 and 4 will be my final answer. Okay, that's all for this video. If you found this video helpful, please like and subscribe. It helps me make more videos like this, and thank you so much for watching. I'll see you in the next one.